This is our last section of notes for circles. We're going to be looking at writing the equation of circles and graphing circles. This is an activity that I would like to have done with you, but I will do for you and go through and how to come up with the equation of a circle. All right, so I have a circle, and it is on the coordinate plane, and I have a random point chosen, XY. It has nice coordinates here, which makes it easy for us, but eventually we'll get to where it doesn't have nice coordinates. So my process is to create a line segment from the center of the circle to the point XY. Draw that here, and I'm going to label that R. I label it R because it is the radius. All right, so this line segment is called the radius. There are plenty of radii that I could draw on into the circle, but we're going to draw it here. Then I'm going to construct a right triangle with R as the hypotenuse. So kind of like when we used the distance formula, but I used the Pythagorean theorem, I'm going to create a right triangle where this is my hypotenuse. So I'm going to go straight down and then over from the origin, and there I have a right triangle. So the coordinates of point XY, I can see it from the center. I went over 2, up 4. So the coordinates for this point are 2, 4. So to find the measure or the length of R, I'm going to use the Pythagorean theorem. So this side is 2. This side is 4. So 2 squared plus 4 squared equals R squared. I have 4 plus 16 equals R squared. So 20 equals R squared. 20 is not a perfect square, but I can square root it. I can break this down into 4 times 5, so I'll end up with 2 times the square root of 5 for R. And then I can get out my handy dandy calculator and estimate 2 times the square root of 5. And it is approximately 4.47. So when I have a center of 0, 0, and I know how far left and up, right and up I can go, I can find out the length of that radius. All right, in my second part, I have a circle centered at the origin, but I do not have a grid to go with it. So this is just some random point XY. So we're going to kind of do the same steps. So I'm going to construct the radius from the center to the point XY. I'm going to call that R. I'm going to construct a right triangle with R as the hypotenuse. So this would represent being along the x-axis. This is going to be parallel to the y-axis. And then I have my right angle here. So I'm looking for the coordinates at the point where the legs meet. So this is the point 0, 0 from my origin, and I went over. I don't know exactly how far I went over, but it lines up with this x. So this point is x. It didn't go up or down, so it stays at the y value of 0. So the coordinates for the point of meet would be x, 0. So I'm going to write an expression for the distance from the center to the point from number 2. So from this center of the circle to this point here, I went over x units. So that distance is x units, whatever my x value is. Then my step number 4, I'm going to write an expression for the distance from xy, which is the point on my circle, to that point from number 2 here. So from this point to this point, I went straight down. How far down did I go? I went down y units. So this is y units. And then my step 5, use the method from part 1 to write an equation for r squared. So I'm not actually going to find the distance for the radius, but I can write an expression for it. So in my right triangle, this distance is x, and this distance is y. So x squared plus y squared equals r squared. This equation is actually how I write any circle that is centered at the origin with some kind of radius. So if I want to find the radius of some circles, and I have x squared plus y squared equals 49. It is centered at the origin. This is my radius squared. So my radius is 7. If I have x squared plus y squared equals 64, it is centered at the origin, and this is my radius that has been squared. So my radius is 8. If I have x squared plus y squared equals 80, it is centered at the origin. This is my radius after it has been squared. So my radius is going to be equal to the square root of 80. Let me get out my calculator, and I can simplify the square root of 80. So I can write my radius as 4 times the square root of 5, which might be kind of hard to estimate on a graph, which is going to be approximately 8.94 units. So this equation is how I write any circle centered at the origin with a given radius. The radius will be squared in the equation. I'll have another video that will deal with circles that are not centered at the origin.